The aim of our project is to use water more efficiently. This project includes components such as a water pump, a moisture sensor, and a distance sensor. Among the fundamental components we use are a water-filled container, a flower pot, a water pump, a moisture sensor, a distance sensor, and a voltage regulator. The basic functionality of our project involves measuring the moisture level in the flower pot to determine the water needs of the plant, measuring the water level to determine the required amount of water, and using inter-card communication to utilize this data.
Now, let's examine the foundation of the project, soil moisture sensor. Using the STM32F4 MCU, I take data from the soil moisture sensor on log pin because it's more sensitive than the digital pin. It's connected to the ADC pin of the STM32. After that, I send the data to slave 1 using UART, and also I display the sensor data using LCD.
Now, let's talk about the water motor. Using the moisture data received from the master, I ensure the motor operates if the humidity is below a certain threshold. For this, I utilize a voltage regulator. To control the voltage regulator, I opted for the PWM pin of the STM32F3, allowing us to regulate both the motor speed and also motor operation based on the moisture data received from the master. The voltage regulator is powered by 9-volt battery.
I'm measuring the water level in the project by adding a distance sensor. I square-C to retrieve distance data from the sensor. With the distance sensor, I measure the distance above the water container. Then, based on the distance, calculate the remaining water in the container through a mathematical operation. Subsequently, I send this data to the master using UART. The master, equipped with two LCD screens, displays this data on one of them.
Now, let's power up the MCUs and observe our system in action. The data from the humidity sensor is directed to slave 1, controlling our motor. Here, when the humidity level drops below a certain threshold, set at 35%, the motor begins drawing water from the tank and transfers it to the pot at the other end. Concurrently, we monitor the rise in humidity, and if it surpasses 35%, the water motor stops. To keep track of the water level in the tank, we use the distance sensor to send data from slave 2 to the master via UART. We have two LCD screens connected to the master. One displays the humidity level and whether the motor is operating, while the other indicates the water level in the tank. If the water falls below a certain level, it displays a warning. Currently, as our humidity is sufficient, the motor is not running. Now, for a test, I am taking the sensor outside. As you can see, water flow has started. Upon returning it inside, the motor stops, confirming that our system is functioning healthily.